Okay, so welcome team. Um, so today we are exploring the sixth session of the bootcamp, and then we are exploring the Amazon Bedrock, Amazon flows, basically flows on the Bedrock to create a RAG application. So yesterday I have given you some overview of the platform. So today we will go ahead and explore how to create those vector database or the knowledge database, knowledge base that it's called in Amazon, and then how to connect in the components in the RAG. It's slightly not behaving well, the LLMs today. So we'll see how the output comes. Sometimes I get a good output, sometimes not, because there is a lot of tuning and different models you need to try out and see. So just look at the components and how the flow is working. Don't focus on what the output is, basically. Okay. So the output is what something you still need to do fine tuning, change your prompts, change how the output is coming. So there are a lot of things that you need to check those. So I said focus on the uh, flow, focus on the process, how to build that pipeline or the RAG application using the Bedrock, and what are the components that we have. Okay. So hey Raju is also here. Who are we missing today? I think Nabi. Murali is here. Anshu. Okay, so I think we are only missing Nabi today. Check if he's joining. Just I think he is busy. Okay, I think maybe he's busy with some production support things, but yeah. Okay, so yesterday we looked at this Amazon Bedrock, right? So as I said, anybody created this Bedrock? And check this. Okay, so in the services, right, you have a lot of services in the Amazon. So one of the service is S3, basically what you use for storage. Okay. IAM is your identity access management. To create roles, users, you would use this. And Bedrock is what we are exploring today for the RAG application. Okay. So if you go to IAM, then you will have users and roles and all of that. So once you log in, you have a root user and you also have another user. So what I am using is my username that I created, Harun. And then I have given this user the admin access, administrator access. So basically you get everything just like a root user, but there are some services strictly you cannot create using the root user. So you have to use the administrator, you have to use the IAM role or IAM user. So that's why I used this user, create one user, and then just give admin access, and then use that user when you log in, basically. So I will show you, right? So when you log in, you can just put your, see here, account ID and your user and password. So that's how I can use that to log in. So once go there, go back. So that's the IAM user setup. And there's something called S3, Amazon S3, simple storage service. So where you create, buckets. Buckets are simply your folders, just like in your laptop or in your computer, you create folders and then you put files in it. The same, you create buckets here and then you keep adding your data into these buckets. So there's a whole lot of, you can give access to a particular bucket. You can make it public, give access by roles, and all of that you can do. You can control basically who can access and what type of access you can give on each of those buckets or into your files. You can simply go create bucket, just leave general purpose, then say test bucket. Okay. And then you can choose from existing bucket. If you want any settings, you can choose any existing bucket, or you can just leave it all of this AZL disabled default. So don't do, remove this, block all public access. I know it is, this is for testing. Okay, so normally you would block all the public access and you give very specific access to the users. And then you can say acknowledge. Bucket versioning we don't need. So bucket key enable and everything. Okay. So simply just uncheck this, acknowledge. Okay. Give the bucket name, general purpose, and then go create bucket. For case characters. Same name already exists. What? Okay. Let's put some name and then say create bucket. So you get the bucket here, test bucket Harun, access analyzer, where in which region it is created, creation date, and all of this. So once you go here, you can go click on the bucket. Then here you can go and upload your files, just like you do your on your Google Drive, right? Same thing like this. You can upload your files here. So you go here, say add files, and then it will, ask you what files you want to upload. Just upload whatever files you want, and then click on upload. So that's it. Your bucket is created. S3 is created. Now, this is the S3 is a normal storage, not just for you to upload your files. Something it is.
Harun, we lost you for a bit.
Oh, okay.
Where you were showing the file upload.
Okay, that just like you go here and so basically you go upload, add files, and then select your files, and then open and go here and say upload. So your files will be uploaded. Okay. So it's not just for users to upload your files. It's basically a very powerful. It's the entire Amazon storage that works on. All the organizations, companies use a lot this Amazon S3 storage, S3 storage as a default storage for their files or data, basically, right? So this S3 you can connect from many of the AWS services, or even outside also using your S3 URI. For the bucket you can give, or for the files you can give this URI, and then if you go here, you can select this and copy ARN. Okay, this is resource something unique ID. So you can copy this, and then you can provide it for access, and then you can define who can have access on this bucket, and all of that is a different scope, not here. But I'm just telling you how you create bucket and then how you have your files. So this is another bucket. I have movies.csv here, file, same thing like that. So that is your S3, creating buckets and uploading your files. Just like in Python, you are uploading, in Colab, you are uploading your files. So here you use Amazon S3 service. Okay. Now, when you go to Bedrock, Amazon Bedrock. So we were seeing yesterday, there is something called knowledge bases. Okay. So chat, text, image, video, we have looked at yesterday, and then we looked at flows. We will go to flows. So when you go to flows, you can create all of those components and rack pipeline, but you can also attach, attach the knowledge base. You can also attach the knowledge base as your vector search, that entire thing, right, that we were looking at. So if we go here, so this vector database, embeddings, query, so all of this left part and all of that will be built into the knowledge base. So this store raw data sources where you are seeing this is your S3 that we have just uploaded the files. So you can use this storage files and then create your knowledge base with the vector database here. So how do we go about it? Creating a knowledge base. You can create knowledge base with vector store or with structured data store or with Kendra GenAI index. Okay, so this is a different offering out of the box, high semantic accuracy and flexibility across Amazon Q Business and Bedrock knowledge bases. So this is just with the vector store, customizable knowledge base, location of your data, embedding model, vector store, Bedrock stores, and update your embeddings, everything. So we'll go here and say create knowledge base with vector store. Okay. So here you want knowledge base name. So you can just give something test knowledge base. Leave it default. Leave it Amazon S3 is your data source. Okay. And then when you go next, configure data source. It will ask you where is your S3 data source. So what is your data source name? You'll just use this data source. And here you have to give your S3 location. What is your location in the S3? So this is this AWS account. You can say browse S3. It will take you to all the buckets you have access to. So you can select your bucket here, S3 URI, Amazon Bedrock default parser, leave all default options, go to next. And then here you can choose your embeddings model, right? So remember here, so this is your S3. Now you are creating a vector store out of this database. So you have to choose the embedding model. So how do you embed this, right? So that embedding model you can choose here. So let's say I'm using Titan text embeddings V2. And then you select a vector database after the embeddings, right? So you have, this is S3, this is embedding model you selected. Now you have to select the vector database. So come back here, we create a new vector store. Okay. And then I'm using Amazon OpenSearch serverless. This is the vector store. Okay. You can also use Amazon Aurora PostgreSQL serverless or Neptune Analytics Graph Rack, any of these. So I'll just leave this here. So when you do this, see now you come here, it says your model Titan text embeddings V2 has vector dimensions of 1024. A vector store is default Amazon OpenSearch serverless vector store that you are using. So this is same as using Chroma or Pinecone or PG vector, right? So same thing. So you also have that PG vector is same as what you are seeing, that Postgres thing, right? On Aurora, Amazon Aurora Postgres. So that also you can use. So these are all the options. You have knowledge base name, you have the file storage, S3 URI you gave the embeddings model, what embedding model you should use, you gave the vector store, what you created the vector store. So let's say you create the knowledge base here. Once you do that, it will automatically create the knowledge base. So it says this may take several minutes to complete. It will take some time. But meanwhile, let's come here. So this is the same knowledge base I have created again. If you see the data source is S3 I have used, and the same bucket which had the movies file in that uploaded, right? And then default chunking I used. This is the account ID, data source S3, and then I used the data source here to create the knowledge base. And then embedding model was also selected within that when I created this. So we cannot, it's not visible. It's here. Titan text embeddings V2, 1024 dimensions I use. Amazon OpenSearch serverless I used. This is automatically created. Index name, field name. So these are by default it has created. So remember what we did once we create the vector store, we tested with the retrieval, right? So we gave some number of semantic search options that we wanted to do. So I can test the knowledge base and then say use generate responses. I used this model to generate the responses from the retrieval, and I used this question. Okay. What are the children movies released in 1995? And run. So it gave me these ones: Toy Story, Jumanji, Tom and Huck, Balto, Free Willy, 2, The Adventure Home, Babe. Okay. So if you go show details, now it will show you what happened. What is the source? So you remember we get, when you do a retrieve from vector database, you get chunks, right? So source is, this is chunk 1. This is the source. Now this is chunk 2 and this is chunk 3. So we got 3 chunks from the vector store, and then this model took it from there and extracted these names where we thought that are children. Children is basically where it sees the genre as children. Okay. So Toy Story is there. So Toy Story is children. It has children genre in the Toy Story. So it gave me Toy Story. Then Jumanji it gave me. Okay. And so whatever. So all of those which came from this chunks. Now if I go here and say, I can go home and check. What do we want to check? Let's say the adventure home, right? So the adventure home, if we search in our file, okay, and see whether it has children or not. Okay. So this is the adventure home is already there as children. So it is basically it's Free Willy to the adventure home. Sorry. The entire thing is 1. Okay. So that's what it gave me, Free Willy to the adventure home. Okay. And Babe. So it kind of again gives you the chunk 1, 2, 3 where it is taking these things from here. So this is your retrieval, right? From vector store you created, and then you are doing a retrieval from the knowledge base. So you have uploaded the file onto S3, you have created S3 bucket and uploaded files. You created a knowledge base based on that source you gave it as S3 bucket. Then you provided an embedding model. Then you provided Amazon serverless vector store, vector database, OpenSearch serverless, and embedding models. And then you created the retrieval. So you can test this retrieval. So when you are retrieving, so here it is like, I said generate responses from these sources. Okay. So if I don't do that, it should actually throw me just these things, right? So it'll just show me the 3 chunks. That's what retriever does, right? It will give you whatever chunks it is matching with based on the index. It will throw you. So those are it should do that. I am not sure. Sometimes it's not behaving well. Where does it go? Oops, I lost it. Okay, you can type again. What are the children movies in 1995? Okay, anyways, it still works. Okay, sometime. Oh no, because I'm using the same thing. So, let's see. This is because I'm using another LLM model to take those and then format this here. So let's say I'm just don't generate responses, just search and see what happens. See here. So now this is the basic retrieval. So it's giving you the 4-5 chunks that are matching with children. Anywhere it sees in that chunk as children or children movies are there in that chunk, it gives you all of this. Okay, any questions? So meanwhile, yeah, this is also done. Basically, it's the same thing. And then you can go and so you have to first sync these data sources here. Select this and then run sync. So it will sync the latest data source. Then this is enabled. Then you can go and test your model. You can generate responses or you can just check the retrieval model. Are we good? Any questions, guys?
Yeah.
Get this part?
Yes, yeah.
Internet connection. Ramya, Hema?
Yes, sir.
Yes, sir.
Raju?
Yeah.
Okay, nice. Pawan?
Good, sir.
Okay, nice. All right. Um, so basically, so that's the creating the knowledge base. Okay. Now, what's the next part that we want to do after creating the knowledge bases? So what we actually wanted to do is do a RAG application, right? End-to-end flow. Okay. So let's say I want to create a flow. We said we want to create test a RAG flow. Test, create and use new service role, create. So this is our RAG flow. So input, whatever we give, and this is the output. So at the base thing, what we want to do, so let's say I want to add a model here. So model is like, your prompt. Okay. So you define in node, select a model, let's go to Nova Light, apply. Guardrails you can create. So provide a brief answer for the question, user input. So you have to give in the variables. So just put double quote. So see here it will get enabled. The circle where it can take input now because it has you created a variable. If you don't create variable, if there is no variable, see now it's not defined. So you cannot connect this here. So you give input curly double curly braces. So this input is enabled. Now what I will do, move this, take this, connect the input to this prompt. So this has a model that will complete. So it uses a model to answer. Okay, Nova Light 1 on-demand model. So this output I am connecting to the flow output. Okay, so that's at the base level, my the level 1 where I can create a user chatbot with a model. You ask a question, the model will answer. That's it. Okay, so I go here. Sorry, I have to save this. Okay, changes successfully saved. Now I go here. This is testing my flow. And then I say, who is Alexander? Run. Okay. Several notable famous ruler or the historical or comparative contemporary figures. So you can also see a trace here, show trace. So it will tell you what is the flow that was executed in the pipeline in your application. So it will tell you what is flow input node, what is your question in the prompt. So document what was the input received and output. So what was the output sent from this prompt, this model, and then what is the input received from or input or output, whatever flow output node, the same thing that the model has sent out. So this is, you can check the trace for your application. Okay, so this is at the base level. Now, how do I make sure it is answered from our input, right? Custom input, basically from my file. Okay, so for that, what I have to do, I have to connect this flow prompt to my knowledge base, correct? So vector database basically to retrieve the results, right? So that's what I have to do. So to do that, let's see here. How do we connect? We get input. So let me, so this is not here. So let me go here. I have the application so we can walk you through here. So this is the simpler RAG that you can look at. Okay. So flow is the input. Again, I am doing just the input flow input here. So from the input, I am sending it to a knowledge base. So what is the knowledge base is basically your vector store, right? So how do you give that knowledge store? So you can select whatever knowledge base you have created here, right? So what is your knowledge base you have created? The name. So here knowledge base quick start test. What are all the knowledge bases you have? Okay. Knowledge base movies data sets. It was the ones I created. Knowledge base quick start test that we just now created. So knowledge base movies data set is what I have selected here. Okay. And then you say generate responses based on retrieved results. So then you give a model that it can take those responses and send an output. I used, so you will get a, once you go here, I will show you that. So you get Claude V2.1 model, and then you can add guardrails also here once you create. And then the output is basically sent to your prompt. So prompt is just taking all this input and then formatting again using a different model. So I have given the message here, extract movie title and release year and genre and provide as list from input. I don't know. That's what I said. It's taking the input and throwing whatever output it has. Model completion. There's a lot of tuning that is required for this kind of data set because this is highly unstructured data. Correct? So it has to understand the year is this part. It has to understand this is the title. It has to understand these are all the genres because we have not, so it needs some training, like a few short examples, so those kind of things in the RAG. And then you have to add all of that into the your prompt. So basically that's when you will start seeing the results when you add in the prompt message. Okay. And then this is the flow output. So you can go here and see if I do what are children movies released in 1995. So here is the list of movies released. Babe, Balto, Jumanji, all of these things. It gave 7 names. Okay. And then if you go to show trace, now it will tell you which flow was executed. Now this is the flow. What are the children movies released that I have asked question. So from there, it went to knowledge base. In the knowledge base, the same question and the output trace it gave in this structure, in this format. The children movies released in 95 based on search results, all of this like this. Okay. So this is the output. Now it came to prompt for this model. So that is the same input that is received from the previous one. Okay. And then output trace is this. So it's reformatted with title and year. So there might be some, duplicates or whatever. Or no, there are no duplicates. The same. So some of the movies that is released. And then that is what is the output that we received here. Flow output total. So this is the a trace that you can see how this is executed. Now, why is this important? This is important when you have different branches, okay, based on the conditions. So we can add a condition. Basically, if you go here, yeah. So here, so you can add a condition as well. Okay, and you can connect whatever input to this condition, and based on the condition you can connect to different one you can send it to knowledge base, one you can send it to generic model if you want to answer the questions. But condition is first you will classify the model output as generic or particular case. So you have to work on that. There's some kind of troubleshooting that you need to do. I will check on that. But for doing this is what you need for the to show the trace, how the outflow is doing. But basically, yes, you can see here, even though you're using your model here, it still takes only the input from the knowledge base and answers based on that question. Okay. Maybe you can test if it answers this. Because there are no responses from the knowledge base. So it didn't show any answer. So it's blank basically. So it only gets you whatever is there in your knowledge base. So that's why you have to also make sure when you have a different condition, right? So if it is not found in the knowledge base or if it's not related to your knowledge base, you want to route it to a different different model to answer generic questions. Okay. Any questions on this?
So Arun, first time it showed only, here it is not showing the chunks, right?
No, here it is not showing the chunks because you have already, see here in the knowledge base, you are saying generate responses based on retrieved results.
Oh, okay.
You are already passing all those things through another model, which is taking those results and then processing it and giving you a text. Maybe you can use this.
So it takes in the vector
Vector search, but I think the input will not work here because input is a string and then you are sending in as a vector store. So it might throw an error. Yeah, see here. So it has incompatible type array string. So your retrieval results will come as an array, but your prompt is taking as input. Okay, so that's why it cannot show the results here. So you have to be converted into a string. That's why we are using the model to convert into, process it and convert it. So when you have a RAG, you don't need to do the source of the chunks, right? This is gone. Yeah, now it works fine. So basically, you can explore more. I've just given you the outline of no code. So you are not writing any code here. Okay. So based on this, you are just going to do, connect all of these nodes basically here. Oh my God, where did it go? Um, okay, so this is another one. So what I was saying is, So if you see, look at this, right? Flow. So this is another pipeline. What I was saying, so we want to put a condition. If you want to have a condition. So here I have an input, flow input, configure. And then I'm using a model to categorize the input. So I used some, Llama 3 8B on demand model. So then I'm giving a message saying that classify the user input as M if the input is related to movies, G for general questions. Only respond with category as M or G. But this I have added. As I said, there is some issue with the output. We need to fine tune that. User input is input. So what I'm doing, I'm passing the input, okay, to this new model. First to categorize the input, whether it is a movies or it is a general question. Now I have created a condition. So this condition will read from the output here. So we will get as M or G, right? So what I'm doing here in the condition, so I'm writing condition input equal to M. Basically, I don't need this. As I said, there is some issue with this. If it is M, okay, it is a default. If it is M, sorry, not default. If it is M, I'm saying go to node. If it is M, which node? I'm connecting this to my knowledge base. So if it is a movie, it is categorized, user input is categorized as movie, then you go to knowledge base to answer the question. So once you go to knowledge base, it also needs the user query, right? So user query and knowledge base, it will give you the output. The same knowledge base that we are using here, it will take the knowledge base, user input, and a model to generate the output. And then you get this output. Now, if the condition is not M or it is a G, then if all conditions are false, this is the default node. So here what I'm doing is I'm just sending it to a generic model. So remember, see this. So here I'm sending to this prompt. This prompt is basically again Claude V2, some model I'm using to answer the question and sending the input. So input is again basically my user input question, whatever question I'm passing to this prompt, and then output I'm giving it to the flow. So basically there are two branches here. Okay. So first, based on the input, I'm categorizing the input using a model. And if the category is M, I'm sending it to my knowledge base. So answer from the knowledge base. If the category is not M, then I'm sending it to a generic model to answer the question. Okay. So this is the flow. Now you can go and check this. Okay. Now, so again, I will ask, what are children movies in 1995? So this is the answer it gave me. Okay. Now, if I go to show trace, categorize input, what are children movies? It is categorizing as M, but I don't know why it's some issue with this. It's giving some new line characters here. Because of this, it's not going to the so it's a flow input node. When you go to condition node, it's going into the default. Okay, it's not going to the knowledge base. So you don't see that knowledge base being triggered in this flow. It's going to prompt 2 from here. So prompt 2 is generic, right? So it's giving from the generic model output, not from your knowledge base. So that's what is happening here. But I don't know why that new lines are coming in, why it is not able to match the condition output here. Okay. but we can try to swap that. Okay, so all we want to do is, these are the things that you can troubleshoot anytime, but all we want to see is how the flow is happening, right? So let me okay, so let me delete this, delete this. So now I will just connect this default node to knowledge base, and this I will connect to prompt. Okay, I just swapped. Let's see, I'm not sure, I'm just trying live. Let's see how it behaves. See, we are getting some information from the file, but it's not as expected. It's basically some junk data that we are getting. Okay, so it's not able to understand what we are asking on this file. On the retrieval, it's working fine if we add just a model, but here it's not able to understand. So we have to kind of fine tune that. Oops, what happened? Okay, so if I just give movies, whatever, it still goes to that flow input node. You're still getting M, condition trace, default. So from here it goes to, oh, it worked this time. See, that's what it's and కొంచెం ఆడుగా బిహేవ్ చేస్తుంది. See, now it you see categorize input, movies, it gave M. So we put now here flow input node, condition node, it didn't document is M, it went to default. Okay, it's not matching. So default we connected to knowledge base, retrieval query movies. So output is this search results. See, now it is getting from the file. Okay, now once we get this flow output, we are formatting. Okay, పరువు కాపాడింది. So this is working as expected. So based on the condition, the only thing now we need to troubleshoot is why the output, instead of just M, it is giving two new line characters before that M, and that's why it's not able to match the condition. So that we have to figure out. But you understand the flow, right? So that's how the flow happens, and that you can see in the trace. So these are all the components that you have to check, create the flows here. Okay. You can further explore. There is something called Amazon Lex. You can further explore, but I think this is the RAG what we are talking about. This is the no code. So in the entire thing, have you written any code here? The entire RAG?
No.
Right? So without writing a single line of code, you are able to create the RAG. You are able to get the answers from your knowledge base. Right? So this is the POC. So if you want to run a POC for your customer, for your company, you can just run this and show them. However, the the devil lies in the detail. Basically, you have seen how it is kind of hallucinating or throwing inconsistent behavior, right? So that we saw earlier. So based on that, you have to make sure that's the model evaluation basically. So we have been using left and right whatever model we could see. So the main job is not creating this. Creating this is easy, 10 minutes task. Now you know what components to connect. Now the actual work is to understand which model is giving you the correct format answers, giving it a proper prompt. We learned, right? Prompt engineering, a few short examples or chain of thought for it to understand and give you what kind of response, right? And then what models you want to do. You put guardrails, you put a proper prompt message to get the proper answer. You evaluate the model. Are you getting all the answers or it's only giving few answers? Does the retrieval model, you're giving top 3. So what if there are some children movies in the other chunks that it has not returned? Are you getting all the responses, all the children movies in 95 when you do this here? So you can verify, cross-check using your source file. So how do you validate a model? So one option is use the same source, okay, and then build a data engineering pipeline. If you have already done, most of you, the data engineering, right? So this is what we will be doing in the data engineering. Also, you ingest this data, you go into the transformation layer, you kind of split this up into different columns, and then what you call blow it up for each of the genres, and then you store the data in the database. Now you can run your SQL and get the output and compare that output on using this. Okay. Now, let's say you don't, how do you do it? It's manual, right? So let's say you want to do that. So you can use another LLM as judge. Now you get the response from this. Use a SQL tool. Okay. You can also create a tool which can take your text as SQL, convert your text into SQL, go to the table database and get you responses. And then you can use the LLM as judge to evaluate, compare these two responses and give you, an answer. Hey, are these responses close as per the SQL? Are we getting close enough matches? Is it 90%, 95%? So these are all the kind of evaluations that you do with the models. And how do you do the tuning? So these are advanced topics: evaluation, the deployment, monitoring, lineage, and tuning. So there are 4 or 5 concepts that are advanced, that you can explore later, or we can, full-fledged, full training kind of thing. So this is your basics, how to build the low code, no code, almost low code, no code you call, using the Amazon Bedrock. Fine. Any questions?
No. So only thing is the code part, we give that input as one code, right? So without that, anything we can add, I mean, as per the scenario.
What input as code?
No, we added that input as that one, right?
This one? Condition?
No, condition somewhere you included, right? As an input something.
Yeah, this one.
No, you included that in the square brackets, some code, right?
Oh, so those are variables.
Variables, yeah.
So if you have in the prompts, right? So you should put this input variables. This is the input that you are getting here. It will enable this field. Okay, so maybe you can also put, I'm not sure, system message. If you put, see, so it will enable another variable called system, another field called system. So you can just connect this from here, or you can create another flow input that will give the system message to this prompt, something like that. So, but both of these are flowing from here. So it's just like when you call functions, you pass parameters, right? Variables. So that's what it's doing here dynamically based on what parameters that you enable. So it will give you, it will accept those parameters. Now, how do you pass those parameters? It depends on from where you are passing those to read. Okay. Okay. All right. Any other questions? All good? Hema, Ramya,
It's a lot
Ravan?
of practice, so we will take some time.
Yeah,
Yeah,
all good, sir.
I know. Okay. Yeah, so that's what, right? So we are taking very slow, introducing only one concept at a time, right? So this is all about Amazon Bedrock and Amazon Flows to build the RAG and models. But at least now you understand, right? It's very freely you can add models. You can create S3 buckets. You have to create a knowledge base where you can do vector retrieval. So all of this you can practice using the Amazon S3. Now, so another low code tool or no code tool that we talked about is Langflow. Okay, data stacks. The similar thing I talked about, you have to create. What happened? So you have to create an account with your email. So I will just give you overview of this, and tomorrow we'll continue creating the things. I think we have already done this, right? Yesterday, I have shown you a few things in this templates and all of that. Yes, so we already done that. So tomorrow we will go ahead and build the. I don't want to overwhelm you. Tomorrow we can go ahead and build the RAG and then add the agents to it. So this is the end application, what it would look like. So we will go through all of these components, just like we have seen RAG, connecting. Same thing we will use in this to create an agentic system. It's basically same. It will be like input, output. There's some models that you use, data stacks. So here it is AstraDB, where you will use for vector search that we have created. You can do all models. There's another AstraDB application token. And then we are using Grok model here. Create some agents and then use this. Okay. So we'll go through this tomorrow. How you're building all of this from the file, your file splitter, chunk sizes, and then vector search, all of that. Okay. We have gone through all of this yesterday, so I don't want to again repeat this, but we will take this up tomorrow. So today you can go on explore the Amazon Bedrock, and this will be our final session tomorrow, and then Thursday we can just meet to do any hands-on if you guys want to, or just review few things and wrap up on Thursday. We can review some of the concepts if you want to. All right. So these sessions will be shorter now, last 3 sessions, because we are almost doing 8 sessions now. So I don't want to keep adding more stuff on a day-to-day basis. So for now, today, take this Bedrock and look at it, try to practice. I will upload the video as well. And tomorrow we will go through the building a RAG or agentic AI using Langflow. All right, so that was it for today. Now we'll take any questions, feedback. Are you comfortable, or at least understand from all the concepts that we have covered? Are you feeling anything else that needs to be covered? I mean, I know there are a lot of things, but at least from the basic, from the bootcamp perspective, do you think we are missing something that should be there or anything like that?
Yeah, so yeah, it's looking good. And yeah, only thing is how we can implement the real-time scenarios. So if we explain such kind of things, it would be great for us, I think.
Yeah, that's real-time scenarios, use case projects kind of a thing. See, this is almost close to the real-time scenarios only, whatever we are doing. You just have to replace the movies file with your actual data files, right? So that's the POC that we are doing. What in the
Yeah, because
real-time scenarios,
real-time
for
actually,
example, you are creating a customer service chatbot using a RAG. So that is the complete solution here, right? A RAG chatbot. All you have to do is put all your manuals. We did on the first day itself, right? So put all of your manuals, FAQs, everything, files, dump into one place, and then run the RAG. That's your chatbot right there, POC.
yeah,
And
so we are
yeah,
going only one file only. So usually the
no,
real-time
you
scenario.
can dump any number of files. You can put 10 files, 100 files. It's just a volume, right? Resources.
Okay, so different files, but how we can connect? I mean, if, for example, the real-time scenario, if you take a customer scenario, so he buys some products, right? And
Mhm.
also he has some address as well, and he has some bank transactions as well. So these are all different things. For example, okay, Murali, if I type it as a chat GPT kind of thing, okay, what the details of Murali, just Murali, if you give something. So the results, what I expect is, okay, Murali is a customer, he lives in Phoenix, and this is the address, and these are the transactions, and this is his credit or bank account. So I expect that one as a result, right? So last month he bought these many things from our store or something.
Yeah. Yeah. So that's a good scenario, right? So now break it down into pieces. You have all of that information. So what is the data source that you have? You need to have a customer database, a customer table. You need to have orders table. You need to have addresses table. Basically, all the let's say data model for customer and his history, 360-degree view, right? Now, how do you build that application? Is you have to provide, say, all of the tables. You have to tag with information. Okay, so each table will have a tag saying that, hey, what kind of information is available in this table. Now, that is for the AI to understand which table to look for particular information. So that is step one. So you tag all your tables, you classify your data. saying that, hey, this table has your customer information, this table has order information, this table has customer addresses information, and all of that. And then probably you would also give, this is a child table of the customer, and then this is the key that, you can join the customer ID with the customer, something like that. If it is not explicit, that is your setup. Then you create a tool. Okay. A tool, a SQL tool. Basically, you can create a tool. A tool is basically, you can say, a SQL function. So if you talk about Databricks, you can see all of those tables. You can also have all of those tags that you write. Let me see if I can log in and walk you through. So whatever you're saying is a relational database that you can provide. It's not the file based, right? You don't have all of your customer data in the files. You don't export it to files. Or if you want to, you can just put all of those files as S3 files and then do it. But logically, that's not what you want to do. So if you go here, let's say in the catalog, you go here and then you go here, tables.
Harun, you are not sharing your screen.
I'm not sharing. Okay, sorry. Let me share my screen. Okay. So in the Databricks environment, right? So you go to catalog, tables, docs, text. So here you will have something. History details. Here, see, you would have tags. You can add tags, and then you have a description, AI suggested description that you want to put. So this is what will help the AI to understand what kind of data you are holding in a table. The docs text table contains text data related to documents. This table serves as repository for blah, 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 various documents within business. Text stored can be used for analysis, search, or retrieval. Text column holds the actual textual information of the documents. So all of this is your description. Okay. So it will go into your description, and then you can also add tags. Okay. So whatever key value. So if you say customer, you can add customer and then tag customer data as a value, name, whatever you want to add tags. That will help AI when it goes through the metadata to understand what tables it has to choose from. Okay, so that's the first step. Now, once you have all of that in the tables, all the information, then you can create a so what is this filter space? See, ask questions about your data in natural language. So this is something from Databricks. This is a text to SQL. So you write your text, it will convert to SQL, and it understands which tables to search for, which tables to join to get you the information. So basically, that's how you can build that tool. So once you build that SQL function, then you can use it as a tool and give it to an agent, and then use the agentic AI RAG. So when the customer asks question, the agent will understand, hey, this has to be answered by the SQL data or the repository. So it will send that, it will use that SQL function tool and send that query. So that query will be now converted to SQL, and then the response will be given using this Genie project. So there are ways and tools. It's not like everything is just drag and drop and done. If it's that simple, then we don't need to do all of this thing. But I understand. So it's a scenario, a valid scenario, and then there are solutions, but it's not that simple solution. You have to build all of these building blocks, where you will have that basically text to SQL kind of SQL functions. So let me, so SQL functions as agents in GenAI. Okay. So there is something called SQL AI functions. Now you can explore that. AI functions. So in public review. So there's a AI query function. So vector search. Let's see. AI analyze sentiment. So you can call this function and pass your content. So this is the SQL you have to write for that function, right? AI analyze sentiment. Example, I am happy. So you are calling this function and then it will return this positive, negative on that, classify function. Similarly, AI similarity function. So these are all like built-in functions that you can also build function and then use it as a tool for the RAG application or the agent. So AI similarity, string 1, string 2. If you say send 2 things, it will compare and give you some score. Right? So see AI functions, query LLMs with SQL. So SQL AI functions you can use. So basically, yeah. So you have to explore how you can build those SQL functions, getting those, giving your database structure to the SQL function to give you. So I think there is a data AI presentation on Genie Databricks. AI BI October. So search for this. They have given the demo on how to use that AI on this. It's called Genie. See here, you can see this. So you just give the English, then it will retrieve total sales for each employee from the database. Can you see this, Murali?
Yes, sir. Yeah.
Yeah. So these are the things that you need to explore and implement for such use cases, scenarios.
Okay. Yeah.
So there is something that demo was done for, the cookie So basically, it will go through and understand and which tables, what joins. It will write all the SQL by itself, generate the data, and give you the response output. So basically, that's what it right. Future is going to be text to SQL. So it's already text to code and also text to SQL. So just like you are giving a prompt and your model is generating the code based on the prompt, the same thing SQL will be there. But since SQL is specific to your database, your tables, your data, you have to provide the implementation, or at least give the proper context to the model. What are your tables, what are your fields, and you can also write your own function and give it as a tool to use those functions to the LLM as a tool to explore. So all of that you can do. Okay.
Yeah, yeah.
You can explore that and probably come back and give us a demo on that.
Yeah, so basically whatever business scenarios and everything we need to study and analyze. So accordingly, we need to design that one, right? I mean the project
Yes.
design.
Yes, definitely. Not a simple RAG or simple LLM will not give you anything. It will just throw
Yeah.
rubbish.
Yeah, those are the basic things which we need to understand before going to
You
the
understand the building blocks, you understand what are the tools you have to build something, and then the actual implementation is using those blocks to build something application. It's like you are using SQL, you learned SQL, you learned Python. But when you want to do an application or a project, you have to use those tools to write code based on the requirements. So similar thing, you have all of these tools that you can use to create a RAG application or to create an agentic AI, that can do things for you like this.
Yeah.
Okay. All right. So any other questions? Anshu, you're good? It's not on audio. Okay. Ramya, Hema, Pavan.
Yeah, Harun.
Okay.
Yeah, good.
All right. So I think that's it. We'll wrap up for today. So tomorrow we will get into the agentic AI with the Langflow on the data stacks, and we will wrap up the bootcamp on Thursday. Okay. Okay. All right, guys. Take care then. Thank you. Appreciate everybody's time. Keep practicing, keep learning. We'll meet tomorrow again, same time, 7:30 CST. Okay. Take care. Bye.
Yeah, thanks, Harun. Bye. Good night.
Thank you, Harun. Bye.
Thank you.